Hi everyone, and welcome to a new episode in the Multiverse video series. Today we're going to learn how to use the tune package with Spark and R. So what is the tune package? Well, I must say that I'm not an expert on the tune package. You should definitely reach out to the Tidy Models community. But, just kind of like as a quick overview, what you can see is that the goal of the tune package is to facilitate hyperparameter tuning on the Tidy Models packages. And it relies on other packages like recipes, parsnip, and dials. So again, I'm not an expert on this topic, but what is interesting here is that you can use the for each package to run parallel processing with hyperparameter tuning. So suppose that you have a model, and like if you're running hyperparameter tuning on top of this model, it can be pretty slow if you're using a single CPU. So as part of the optimizations kind of like article here, one of the things that you can notice is that there's a section for parallel processing. And basically what parallel processing allows you to do is to use more CPUs or more machines to process the same uh, hyperparameter search in your model. All right, so as you can see here, this is supported by the for each package. So basically the for each package is it's a interface package that allows you to iterate over multiple elements and perform a computation. So it's not very interesting on its own, but what it's really interesting is that the for each package supports multiple backends. So you can use, for instance, do parallel to use multiple CPUs in a single machine, and other cluster technologies like MPI and why not. And this basically makes your grid search faster if you happen to have either multiple CPUs or multiple computers. So one of the newest features that it's currently under active development, but you can already try it out in SparklyR, is a feature that Yitao Li worked on, which is called Do Spark. And basically what this feature allows you to do, if we look at the documentation, would be to basically allows you to use Apache Spark as a backend for the for each package. So again, this is quite early, but still pretty interesting. So one of the things that you can, one of the ways that we can see how this works is by taking a look at some of the unit tests that we have. And just to give you kind of like a quick idea of how this works. So for instance, here what we're doing is we're using the for each package, and we're just checking something like we want to stop a particular condition when something hits the value 10. And again, this is just a for loop. It's not interesting, but when you combine the for each package with backends like Apache Spark, you can basically parallelize support for Spark and your computation. So again, it allows you to basically create a bridge between, like your existing modeling algorithms that you already have and Apache Spark. So in this particular case, going back to the tune package relies on the for each package. So this means that now now you should be able to use Apache Spark in combination with the tune package, which is what we're gonna do in this video. Yeah, so the first thing that you want to do is you want to install the remote packages, and you want to install SparklyR uh, from GitHub. So you want to do something like this, and on the particular SparklyR/SparklyR. Now, I must say that I did a little bit of pre-work before recording this video. So one of the things that I prepared is an EMR cluster. So as you can see here, this is running on Amazon AWS, and I'll link to a gist that I have where I had to do a couple steps before recording this video. So the first one was create a Spark cluster. You can use whichever Spark cluster you already have and support, or you can use many of the available Spark clusters out there. I'm just using EMR because I happen to have an AWS account. Yeah, but you can use these with absolutely any Spark cluster. And in this particular case, I had to fix a couple things. You might not have to do this depending on your cluster. I hit a couple errors when I was installing some of the tidy model packages. So I had to fix it. This is actually unrelated with Spark. You just whichever your Spark cluster is, you would need to get tidy models tuned and some of the dependencies installed. And if that doesn't work, you'll have to troubleshoot that. In my case, it was mostly straightforward, but I did hit this particular issue in EMR, so it might be particular to EMR, but then that's about it. So it wasn't that bad. All right, so that's about it. So what we want to do first is, we can include some of the libraries, since I already run through this particular exercise of installing all the dependencies. And then on the tunes package, there is, we can start with something simple, which is the grid search tutorial. So in this case, we need a few packages, MLBench, and there's going to be a lot of copy paste. So apologies for that, since we're following mostly the tutorial from the tune package. So let's do that. Let's just make sure that it actually executes properly. So that's all good. We're going to skip the error cases, but let's just remove this particular column, which apparently is problematic. All right, and once we remove that particular column, let's define the inputs for our search. So these are where things start getting interesting. So let's define that, and let's also define a recipe for it. And again, if you have questions about it, you should definitely talk to the tune maintainers and in general tidy models. So let's just run this as well, which again, here we're defining the bootstrap. And we don't need to run this, I believe, but let's just do it to avoid any surprises. And control grid. Maybe I do need to use it. Oh yeah, we actually do need it, because then we're going to define the grid with these parameters. All right, so far so good. And the next thing what we want to do is we want to execute tune grid and see the results. Now this is going to take a while. So one of the things that I want to do is I'm not interested on the results, honestly. What I'm interested more is on the performance. So for that, I mean, we could use different tools, but for now we can keep it easy, and we're just gonna use system.time, which basically all it does, it basically records execution time. So we're gonna run that, and again, this is just bare bones, just the bare bones tune package without any optimizations whatsoever. But what I'm interested to see in this video is, well, first of all, does this work with Apache Spark? And second, we expect to see some sort of improvement in execution time when we use multiple nodes and multiple computers. Now, in general, optimization tends to be quite tricky. You want to make sure that you're familiar with Apache Spark, and like things are working properly before you actually run your grid search. But it can be like a pretty useful tool, especially if you have really long models that are just taking really long time to run. You can combine them with cluster computing, being Apache Spark one of the technologies that you can use to save you some time. And again, in this case, I only have a 3 cluster machine, so it's pretty simple. I don't expect to see like huge improvements on performance, but it's fast enough. It should be faster at least than using a single machine. All right, so while this works, let's just take a look at what we're gonna do next. So here are some of the things that we want to do. So as I mentioned, we need to install the remotes package first, and we need to install sparklyr from GitHub. That's just the way it's gonna be for a while, until we release sparklyr 1.2. And yeah, then the next thing that you want to do is, well, we obviously want to include sparklyr, so we can do that while this is running. We'll just see the results afterwards. And then the next thing that you want to do is just to connect to Spark. Now, here is this. You can look at other videos, or you can also consult mastering Spark with R. But in general, it can be quite tricky depending on your Spark cluster configuration to figure out how to get the most out of your cluster. So in this particular case, I only have 3 nodes, but each node has 8 CPUs. So I'm going to try to maximize usage by specifying the number of executor instances to be 24. Now I'm pretty sure we can get these to run faster if we there's a setting on EMR to maximize resource allocation, which I didn't actually use. So we're not gonna get the performance of the 24 cores, I believe. But like this, that's like a good exercise for a different video. Anyway, so definitely one of the things that you want to try to do is maximize your number of executors with single CPUs. So you want to have multiple executors, each one with a single CPU. Okay, so let's take a look at that. All right, so as you can see here, this just finished and it took a little bit more, over 2 minutes, to perform this hyperparameter tuning of this particular grid on the tutorial from the tune package. So let's go ahead and connect to Spark. And once we're connected to Spark, what I recommend you to do is to first validate that you're actually executing, using your cluster properly. And by that, I basically mean you want to make sure that you have enough nodes in your cluster. And you want to also make sure that Spark Apply actually works properly, which is the underlying technology that we're using in this new feature called Do Register Spark. Right, so let's just take a look at this. And EMR requires you to manually kind of like fix your domain names. So we'll fix them for EMR. All right, so let's see, I'm missing something else. All right, so now we're logged into Spark, and what you want to do, what you want to make sure you see here is you want to make sure that there is a good usage of resources. And actually, yeah, the first one, this one is the interesting one because that's the one that is being parallelized across all the executors. So you want to make sure that you see something like this. Here, actually, let's rerun it. The first time that Spark Apply executes, there's some overhead. So let's just rerun that again. Because what you want to do is mostly use of CPU. So let's take a look at this and that. No, that's not what we want to do, but they might still be running. So let's give it a second. Okay, we want to open this one, the one with the 24 executors running. Then we want to take a look at the event timeline. All right, so this looks a little bit better. So it basically, we have some CPUs working and it looks better. You can validate on executors how many do you have. And again, this is not necessarily great. I we should see more executors at this point if you properly configure your cluster to use max utilization, which your system administrator might be able to help you do, and why not? But this is okay. Just just as a trial, just to make sure that things are working properly. This should be enough. All right. So we have our execution time using the standard package. So what we need to do now is we need to register Spark as a backend to for each. And the way you do that is actually quite straightforward. All you need to say is register do Spark and then the name of your connection. What you should also do is just validate that for each has access to those um, executors. And again, right now this is a little bit tricky because I don't think we have the full 24 executors. Um, this is a long story, perhaps for a different video, but at least we have 6 running, and probably Spark is virtualizing the remaining ones. But at the end, this should be an improvement. All right, and then basically we want to execute the same code that we just ran. which looks as follows. So we're going to run it. And again, there's really no change, but the tune package basically makes use of for each. And now we're registering Spark with for each, so it should all just work nicely. And you should be able to see, if you refresh Spark, you should be able to see that Spark is doing meaningful computation. So in this case, there's 2 task runnings probably, and there's a few more. Let's see if something failed, and if failed, no, it hasn't, which is good. Right, so let's just keep looking at these. So now we have 30 tasks running. One of them, some of them are executing here, I believe. Let's see. We should be able to see, yeah, no, this is not the one we want to see. It might be the case that it already finished. Maybe not. Yeah, this looks a bit better. We actually want to see the bulk of them running, which is probably, this might be the main task. You know, Spark might actually, you know, breaks the task into multiple components. Yeah, this looks much better. So you can see here that there's definitely some parallelization going on and working. And again, some of this is virtualized, but you can see that Spark is using, it's parallelizing this computation. And let's just quickly refresh to make sure that this is progressing. So right now we have 8 completed tasks and 20 still running. And if we refresh this, we should be able to see, yeah, I mean, the task could be quite long, so that's all right. We can let it run. We have 16 complete now. Now we have 28 complete, 29, one running, and it should be finished now. So let's just go back here. And as you can see here, yeah, the execution time was about, it was a little bit faster, nothing necessarily significant. There's usually some overhead the first time that something is executed in Spark. So I would expect, like, if you're actually doing multiple iterations of this particular algorithm, overall, it should speed up a little bit. And definitely, you know, you want to make sure that you have a decent size cluster and that you have optimized properly your executors. And why not? As I was mentioning, like, we don't have like the full 24 executors that we would want here. We're actually only using 5 in this particular case, which actually I wonder if I connected properly. Let's see. Yeah, it should be fine. Yeah, there's definitely room for improvement, but what is exciting here is that we're using the tune package in Spark, which is great on its own. So you can definitely expect improvements on performance, which we did have a bit of an improvement, but with a larger cluster, you should be able to see these numbers go significantly down. And again, you can see the parallelization here happening while tune is running, and I'm just hoping that we can see you know, a bit of a clearer speed up from the 2 minutes. Yeah, that makes sense. Okay, so yeah, this is so much better of a run than the previous one. We see that it's almost, it's a little bit slower than 1 minute, so you can almost kind of run this on half the time if you run it in Spark. And again, this is without me optimizing anything on the cluster. You definitely want to spend some good amount of time. You also want to optimize memory, which as you can see in my connection, um, is not even, I'm not even allocating memory for this particular these particular executors. But you know, even with the bare bones, you know, Spark cluster, you can see that there's a good improvement here, and that's pretty exciting. Now, I would recommend you, if you're gonna try this out with the tune package in Spark, definitely, you know, feel free to open GitHub issues for us to take a look. I expect this still gonna take us a couple weeks and maybe a month or so to actually release it. But it's kind of exciting to see these two things working together. All right, so thank you so much. I'm gonna post a link to this gist on the just on the YouTube video, so you can follow it, and if you choose to. And again, thank you so much for taking a look at this video, and we'll keep in touch.